Hi, let's talk about equivalent ratios. Okay, we have already seen what are ratios. When you compare numbers, it is comparison numbers. It is also a scale factor. For example, you enlarge a picture in a particular ratio. Now here we'll talk about equivalent ratios in more details. You have seen what equivalent ratios are. Do you remember? When you multiply by same number or divide by same number, you actually get equivalent ratios. Let's see how now. Okay, let's take an example of our rectangle. Let's say this is one rectangle and we divide it into two equal parts like this, and let's shade them. Let's shade one as red and let's leave the other one unshaded. Correct? Now the question is, what is the ratio of shaded to total number of regions, right? Shaded is 1 out of 2, correct? There are two squares like this in this rectangle and one of them is shaded. So we say that the ratio is 1:2, correct? Now let's take another example. Let's say we have a triangle here, and let me make more triangles out of it. Here we do a midpoint, we'll join like this. How many triangles in all you have? We have 4 triangles in all, right? Let me shade some of them. Let's say 1 I shade, right? So what is the ratio of shaded this time to total number of triangles? It is 1:4. Do you see that? 1:4 triangle is shaded, correct? Now let me take an example like this. Is 1:2 equals to 2:4? Are they same ratios or not? Doesn't look like. But how about times it with 2? If I multiply both by 2, 2 times 1 is 2, 2 times 2 is 4. They look to be equal. Oh, okay, is that equal? Let's see from our rectangle. So this rectangle was divided into 2 portions. One was shaded out of 2. Now let me divide it further. Okay, now how many portions are shaded? 1, 2 out of 1, 2, 3, 4. 2 out of 4 is shaded. So both are same. When both are same, we call them equivalent ratios. Do you understand? So what are equivalent ratios? Ratios which are equal. For example, if I have a ratio 2:3, this could be equal to, I can multiply both by 3, then I'll get what? 2 times 3 is 6 and 3 times 3 is 9. 6:9. We say 2:3 and 6:9 are equivalent ratios. Correct? Now let me give you some more examples. Let's say these are our beads. Let me draw some beads for you. Colored beads. This one is the red one. 1, 2, 3, 4, 5, 6, 7, 8. Let's say I've got red beads here which are 8 in number. And let me have some green beads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what is the ratio of red to green beads? Red to, let me write green with green, okay? What is the ratio of red to green beads? Can you tell me? How many are red and how many are green? 1, 2, 3, 4, 5, 6, 7, 8. 8 red. And how many green? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 green. So green are 16, red are 8. Ratio of red to green beads here is 8:16. But can we have equivalent ratios here? I think we can. How? Let me divide it like this. Let me make groups like this. Do you see these groups? So how many groups we have? 1, 2, 3, 4, 5, 6. So we have 6 groups in all. Do you see that? So in 6 groups, how many are red and how many are green? So 2 groups are red, 1 and 1. 2 groups. So red are 2 and how many are green? 1, 2, 3, 4. 4 are green, correct? They are in the ratio of 2:4. How is 8:16 related with 2:4? They are twice or 4 times. What? So what we did actually, we got to divide them to get this. So if you divide 8 by 4, you get 2. If you divide 16 by 4, you get 4. So the scaling factor is 1/4. Do you see that? Because we made groups of 4. Now, how about if I further divide them like this? Correct? So, how many groups in all we have? You have to work that out and then find the answer. Correct? Similarly, we can have another group. We can have groups of like this. One group, correct? Two group. And our third group. Correct? We can make a group like this. Here, what is the ratio of red to green? In this, one big group is for red. Is that okay? And how many for green? 2, right? So it is 1:2. So what we see here is the same thing can be represented in equivalent ratios. Correct? 8:16 is same as 2:4, which is same as 1:2. How do you get 1:2 from here? You again divide by 2, right? Now, if I divide it some way or the other so that I get a number 4 here, then what should be this? What should be this number? Well, from 1, how will you get 4? When you do times 4. So when you do times 4 to 2, you get 8. So they could be in a ratio of 4:8, correct? So similarly, we can have many different ratios for the same thing, correct? I hope you understand the concept of equivalent ratios, right? So we will say here that 2 or more ratios that represent same comparison. So what are these? These are different ratios, right? So let me write definition. When 2 or more ratios represent same comparison, right? Then what do we say? We say they are equivalent ratios. Do you get it? They are equivalent ratios. Correct? Now, let me give you a problem here. Let us say that we have to make equivalent ratios for these numbers. 8:12 equals to something is to something. So what could be these numbers? Write different ways in which I can say that 8:12 is equivalent to these. Correct? So that is your problem. Think how you can write this ratio 8:12 as all those different numbers. That is an exercise for you, okay? Fine, can you try it? Yes, you should. For example, if I write 2 here, what should come here? Think, how will I get 2 from 8? By dividing it by 4. So divide 12 by 4, get a number here, correct? That is how you can get it, right? Now, it may be difficult for you to get same ratios lower wise. You can multiply also, right? If I write here 16 then what should come here? Like that, you can make equivalent ratios. Correct? A problem for you here is to write in what ratio. Let's say write 4 different on your own. That will be simple, okay? I don't want to really complicate it at this moment. Let me do the first one for you. So first one is easy, that is why, correct? So how do you get 2? Divided by 4. And if you divide 12 by 4, you get the number 3, correct? You can actually work with these numbers also and get here. For example, if I multiply them by 3, then what do I get? 3 times 2 is 6 and 3 times 3 is 9. Do you see? 9 is to 6 is to 9 is also same as 8 is to 12. It is difficult to get otherwise. So sometimes we reduce the ratios to lowest terms and then figure out what the ratio could be. Do you understand? So try to reduce ratios to lowest terms. As you remember, in fractions, we reduce them to lowest terms and then find equivalent fractions. Same is the case with ratios. Try it out and have fun with numbers like 8 is to 12, and you can put any other number, right? You can put 6 is to 18 and then figure it out. That is 1 is to 3, right? Like that. Put some numbers and find 3 equivalent ratios for your ratio. Okay? Thank you.